Hi, as you can see, I'm already running stage 3 here. This is part 3 of a 5-page, or rather 5-stage process. Here we're testing out the clouds, and so you can sort of see that the stage 3 tester class has introduced some new elements, these clouds here. And there's information about the cloud. I still kept a couple of things from the chick. The location and whether or not it's jumping. And then, of course, these clouds I can affect for testing purposes. I can get rid of them by pressing D to delete them. Boom, boom, boom. Or I can make them fall at will by pressing the F key. And then finally I can press H to simulate a hit. So I want to eventually have it so when the chick jumps up, it will show a score above the cloud. So almost there. As you recall, there's 5 stages. We've first loaded the art and the sounds, then we messed with the chick and using the keyboard input last time. This time we're going to look at the clouds more carefully. Next time, stage 4, we're going to look at the controller class, and then finally 5, very quick stage, just packaging it all up into a jar file so you can upload it to your web page, or web server. Let's close this up for now. And let me show you. I'll just get rid of this here for you. I'll delete this so I can show you how to copy and paste it from the source code. The source code, of course, is right here at the Simple Game tutorial. And we'll scroll down to stage 3. So you'll copy and paste the cloud code and the stage 3, and what I didn't show you last time is you would make a new class in your project. Call that stage 3, I guess. Oops. And paste that in place. Paste. There we go. And as before, when you have a brand new applet to run, you might have to select which one, stage 3, and you'll notice that the size is right because I went in and changed the properties so that stage 3, when I edit the parameters, it says 800 and 600. Alright, all that's a little bit of a review. So, if you'd like to move on to stage 4, go right ahead. Otherwise, stick around and I'll show you what's going on first in the tester class in stage 3, and secondly in the cloud class, or a generic enemy class, what the kind of behaviors that you can have in there. So first off, let's scroll here to stage 3. Let's open that up a little bit. So as before, a lot of this looks familiar. The only thing that might be a bit new is the fact that we are now doing clouds. I'm not sure if last time I made a bolder font, but I decided to declare my own font so it's bolder. But we're eventually going to have an enemy controller class that will spawn clouds at a certain rate, that will control the collisions between clouds and decide whether or not the cloud hit the chick, or if the chick hit the cloud, who gets the point, or perhaps who loses a little bit of the life. So what we're going to do in our tester class is we're going to do a few things that we're later going to do in stage 4. Namely, we're going to generate some clouds, which means that we need some sort of spawner. And this way we'll fill up our array list of clouds. And of course, another thing that's going to be in the later one that's going to be in our tester class is updating the clouds. And this, of course, has to tell the cloud whether or not to to move. It gives the limits here, the right and the left. And then, of course, check to see whether or not the cloud has been declared itself dead. Here we're going to control this within the cloud itself. The cloud is going to be sent information when it moves about the right edge and the bottom edge, and the cloud is going to decide itself whether or not it's off screen and should be removed or declare itself as dead. But you could certainly do that in other ways. And then finally, rather than generating a cloud every time we lose a cloud, I threw in this extra little parameter, speed. Right now it's set at 50-50 chance. And that's so that it gives an appearance of the random apparition of clouds, so it doesn't immediately pop up as soon as one goes. It gives you more of a feel that, go ahead and run that again, so that when a cloud comes out, it doesn't immediately generate a new cloud, but it's got a 50-50 chance as each time the screen refreshes. Kind of a more natural feel. And again, this will be part of our cloud controller later. The only thing really to mention that's different too, last time you saw our key pressed class caught for the arrows to move the chick around, but we're going to add a couple other letters, namely H to hit the cloud, to see if it behaves the way it should without actually hitting it. You just say, hey, start behaving like you're a hit. Same thing too, that the dead method, when we set it dead, that it actually does get removed. And F, that's because when we have a cloud go out, it'll either be sent to the left or to the right off screen, and it'll go across, and where and when does it start falling onto our chick is going to be done by random, and when you're testing things out, you may not want to wait for that. So here we've added a letter key F, so that sends the message to tell the cloud to start falling, and that way we can get a better sense if everything is working as we're developing our cloud class. So in the cloud class, here things are kind of collapsed a bit, but like before, we're going to have a rectangle that describes the location and size of the cloud, and we're going to change the size of the cloud a little bit. This stores, of course, the image of the cloud, like we store the image of our last stage when we did the chick. And then the direction. Here, direction dir is going to either be positive or -1, and that tells us whether or not the cloud's moving to the left or to the right. So that way we can have a different speed that's controlled in one place, but whether or not it goes left or right is based upon the direction. There's some Boolean variables, whether or not it has started to fall, going downwards, or whether or not it should be removed because it's off screen. The speed of the cloud, this has to do with how much horizontal movement. That would be like our dx. And the gravity, this has the speed with which it falls. And again, it's kind of like our dy. And another Boolean, whether or not the cloud has been hit, in which case it's out of play, but it'll start ascending with the point total. I've chosen 100 points for that. So the buffered image, here is the constructor, and what we're sent is the image itself that was preloaded, the horizontal location, x and y. This tells us whether or not it's going to be on the right or left hand side of the screen. The altitude, so we would like some variation on the altitude as well, and the size. So if you take a look, so we'd like to have a little variation too of size. Now in the cloud class, we don't determine that variation. That was back here when we spawn a cloud. Let's go back to our spawner here. Actually, I didn't tell you about the paint method in here. But we can. A lot of what's going on in here is going to be later. But like before, we're going to draw the sky and the chick. In the update clouds, we're going to send the move method, and also we're going to draw them. So when we get to update clouds, let me see if we can show you a little bit more about what's going on in update clouds. So update clouds, it tells all the clouds to move, giving the right limit and the bottom limit. Test to see whether or not it's off screen. And then it has to clear out the ones that were chosen to be removed. And then finally, we have a factor of which I've taught you about whether or not it's generated. So let's take a look at the spawn method. Maybe that's what we need to explain a bit better. Where's the spawner? So if we take a look inside of the stage 3, there it is. Here's spawn. So the spawn method neither is the right hand extreme or else it's 0, and there's a 50-50 chance. The altitude, I have this thing called rand_int, which you can see down here. All it is a simple random integer, but I like specifying a minimum and a maximum and then choosing something in between. And so the way I do that is I look at the difference between the minimum and the maximum, including the minimum and maximum, so I add 1 to it. And then that variation between the difference in min and max is added to min, and that way we get a random int because of this typecasting into an int, a random integer from min to max. So I do that several times, so I just wrote my own little method to do that, to have variations of the altitude and variations of the size, something between 60 and 150. And that's what's sent to the cloud constructor. Okay, going back to the cloud constructor, here we have the constructor just takes the information like its image. It presumes it's going to the right, so a multiplier of +1. But if the x direction is not on the left, it'll be a greater value than x. So that means it'll be going to the left. Now we next have to move the starting position off screen, so we don't just see a cloud pop up. We'd like to see the cloud roll in from the left or roll in from the right. And so what we're going to do is we're going to either add or subtract that size, and whether or not it adds or subtracts is that little multiplier specifying the direction. Then of course the bounding box is declared, and I've just determined that rather than setting a height and a width, that we only send the width, and then the height, so it's going to be 60% of that. And initially it's not going to be falling, and initially of course it's not been hit, so it won't be rising, so those are set to false. And then the speed, we'd like to have clouds, the different enemies at different speeds, and so I make some variation, some minimum of 1 for the horizontal change. And again, the gravity, it's not really a big physics engine, it's just the speed of going down, and it's going to be a constant uniform speed. Alright, so that is the constructor. Alright, there's a lot of boring accessor methods, setting a cloud to be dead, or setting it to fall, or whether or not it is dead or fallen or rising, get box. Those are pretty accessor methods that are very straightforward. Even hitting is pretty, we just change the direction so that it's rising once it's hit. What's more interesting is probably the move method. Alright, here's the move method, and again, I've decided to have the cloud keep track of whether or not it's off screen. That might be a little bit backwards, but in order to know if it's off screen, it has to know the right edge and the bottom edge. So if it's fallen and rising, of course, we're going to have a horizontal movement. And then what we're going to do is we're going to have a random selection. One time in a 1,000, it will set itself to start to fall. So most of the time it won't. And if it has been set to fallen, then of course we have to have vertical change in y. So we're going to change the y coordinate rather than the horizontal x coordinate. And of course the direction is set whether or not it's going to be falling, accelerating down, or if it's going to have a nice uniform ascension lifting up. And again, we're subtracting to go up because the vertical location is 0, 0 on the top left corner, and as the numbers increase as you go down vertically. Then the last few lines is just the testing to see whether or not the cloud is off screen. And that does the move method. The last thing to talk about is the draw method. And this is a lot like the chick class. You notice that we use the draw image, and based upon our direction, you'll notice if I scroll over here, if it's going one direction, we want to map it the left with the left. Otherwise, we're going to map the left with the right. And that way it'll have a mirror horizontal reflection of the cloud. And of course, if it was hit and is now showing the score, we would need to show that score. So these three lines set the color to red, set the font to something large, and draws the screen above the box. And that is almost the game. So all we need to do now is get a more complicated controller that manufactures clouds and tests for collisions. But our cloud and our chick are all ready to go as the hero and the villain of this story. Stay tuned. Stage 4, the cloud controller.